Okay, so we'll try the last question here. Let me just bring up my notes. The setup for this question is really similar, except for in this case, we have raw data. Raw data just means that it hasn't been organized or analyzed at all. In this one, it says an oil company claims to have developed a fuel that will increase the distance traveled for every liter of fuel. 10 scooters are filled with 1 liter of normal fuel, and then 10 scooters are filled with 1 liter of new fuel. The distance in kilometers traveled on 1 liter by each scooter are as follows. So we've got the original fuel versus the new fuel. And often you're going to have that situation when you're going to work with a t-test. So old versus new, something's changed versus something old, some situation like that. The difference in this question is that we don't have the mean and we don't have the standard deviation. We could easily calculate that, and that kind of goes back and connects so well with the first 2 units, specifically unit 2 when we did mean, median, mode, and standard deviation. So it says it's known that the fuel consumption follows a normal distribution. Write down a null and alternative hypothesis. So why don't we start with that, and then we'll get to the calculator part. So the first thing we should do is say let the mu1, which is our mean for the first, and mu2 represent the population mean for the distance traveled on the original fuel, if we use their language, and the new fuel, respectively. So then we say, okay, HO is mu1. It will always be the same as mu2. So that's what we're testing. And in every situation that we're going to see with our different tests, it's always going to test whether the null hypothesis is true. The reason that is because the actual analysis, in this case, the test statistics, so the t-test, it looks to see if there's a significant difference between these two. And so that's why we have to do this hypothesis testing stuff, is because that's what the analysis is designed to do. And that's why it will never change. So in this case, we're testing to see if the new fuel allows those scooters to travel further. So if it is better, then the new fuel, which is mu2, distance traveled, will be greater than mu1. So we set that up like that. So mu2 is greater than mu1. And I mentioned it last class, but if you don't, let's say you happen to get that part wrong, it just means that your analysis won't give you the correct answer. The reason is, and I kind of skipped over this, I'm just going to go up slightly. We call this when it is mu less than the other one or mu greater than the other one. This is what's called a one-tailed alternate hypothesis. You don't really need to know that. You won't be tested on that kind of knowledge, but in stats and university, they will talk about one-tailed and two-tailed. What it just means is that here is the distribution of the t-value, which is a normal distribution. And what we're going to see is if it's one-tailed, meaning it's less than the other average, or if it's greater than the other average, it's really just looking at one side of that curve. And like we saw before, this is going to tell me the probability, and it's going to tell me what the p-value is based on where that t-value is located, which ultimately tells me whether or not I'm going to accept or reject the null hypothesis. And so if you do happen to read something that says one-tailed versus this, which is two-tailed, two-tailed means it could be on either side, and the way that that's set up is like we saw with our null hypothesis, where mu1 is equal to mu2, only in a two-tailed you would have mu1 is not equal to mu2. So there's just a difference between the two. And you end up having two tails in this case where your p-value is based on both sides. Again, if you go on in university, which you probably will have stats, you will probably learn more about that, but there is some base behind it that I think is helpful for understanding. But as I said, you really won't be tested on knowledge of that. It's more just if they happen to mention one-tailed versus two-tailed, and that's part of the reason why we get a different answer for does not equal to, less than, or greater than. Okay, so there's our setup. So now we're going to do our test. I'm just going to do it on here just because otherwise I can't record it for the video. So if we go back here, go to your stat button, and we still go over to tests, and we still go to two-sample t-test. This calculator doesn't work well with these things because they're a bit too complex for the calculator. But you remember this part here where we had at the top, it says data or stats? Now we don't want stats, we want data. If I can scroll over, maybe I can't even scroll over. There we go. So in here, it will say something similar to this. You might have it in a different order, but list 1 and list 2. L1 and L2. I think it looks slightly different, eh, Romain? Maybe? Does it look the same? Okay. So what we're going to do is we're going to input the data into L1 and L2. L1 will represent mu1 and L2 will represent mu2. So this is a good reminder about how to input data because it's something we did already in the course. So if you go back again to stat, so press second function quit to get out of that. So second function mode, and go back to stat and press edit. We're going to type in these numbers, so I'm going to shrink this up and I'll type them in. Again, I don't know that this works on this calculator. I tried it before and it didn't work, but maybe it'll work now. I'm not sure. So just put in all your numbers here. And what it will do is it will calculate your mean and standard deviation for you and actually do the t-test based on that. And it will pump all that information out for you. You could always do it separately, find the mean and the standard deviation by using one variable statistics, but this will do it in conjunction with the t-test. Good, I got mine. So now go back to stat, tests, two-sample t-test, data. And we want this one. This is where it looks a bit different. It says mu1 less than mu1. That doesn't make sense, but mu1 less than the other one. Yours will probably say mu2 or x bar, isn't it? Yeah. And then pooled, you have to have it on pooled, and then go down to calculate. And does this one? Yes, it did work. Great. So you should see all of that. So let's say you did have a question on an IB exam that said find the mean, the standard deviation, and do the t-test. You can do that all here because it will give you the mean, it will give you the standard deviation all in one step. So it's a bit quicker than just doing them all in separate steps. So if we write this down, we've got the t-value. So t equals -2 if we round to 3 sig figs, 8.3, I guess. And then P is going to be equal to 0.00561. And, oh, it does say at a significance level of 5%, so that's good. Generally, a significance level is decided before you do a test because let's say I got a number close to 5.05 and I wanted to make the test work, then maybe I'll adjust the significance level to something that makes it work. So you should always write it down and think of it before that if you were being very official. So in this case, we know that our p-value, 0.00561, is definitely less than alpha, which is 0.05. So we say p less than alpha. And therefore, like the previous one we saw, that means that we can reject the null hypothesis. So therefore, we can reject HO in favor of H1. It seems really formal to write that, but you should write that because you can't say, oh, I know now that H1 is true. What we're doing is we're accepting it on a significance level of 5%, which really means I'm 95% confident that we're right. I can't say 100% sure that I'm right, but I can say it with some confidence. And so then, and we conclude in this scenario that the new fuel increases the distance traveled. For the scooters. And this really supports the company's claim. So the company's claim is correct. So often when you see advertisements that say, oh, this thing is now 10% better than it used to be, or it makes things work better, whatever it happens to be, those claims have to be often statistically proven. And to prove them, this is the kind of scenario you have to do. And you have to go through all this rigor in order to accept or decline whatever that thing happens to be. So it's a really useful and widely used test statistic. The nice thing about doing this t-test, like I showed you pages of back information and kind of explanation as to why it is, this process will always be the same. And it really just comes down to setting up your null and alternative hypotheses, plugging this into your calculator, and then stating if it's true or not, and giving a concluding statement. So down on the bottom here, let's say you were to use this for an IA. You probably won't, but you might, who knows. You really should formally go through these steps. In these questions, they've been set up for us to follow kind of a step-by-step process. But let's just say they said, try to prove if this is true or not. You would go through these steps. So formulating the hypothesis, choose your significance level. Generally, that's going to be 5%, but you could make it more stringent or less stringent. It's up to you. And then you would use your data, find the p-value, make decisions, and then interpret your result. And that process will always be the same. Any questions on that? It's all right? Okay, these practice questions you can try. It's not a lot. I think the last one is similar to the one we just did, where you have to plug the information in, but you can try that out and let me know if you have questions.